Let's see how Peru manufactures and maintains mining equipment every day. At the Lima rubber plant, specialists produce polymer mill liners and rubber panels, making equipment lighter and safer for industrial use. In Arequipa, technicians work on overhauling large machines, upgrading components, and performing precision repairs inside a 12,000 square meter facility. The mineral laboratory analyzes ore samples to improve processing. Field crews handle equipment maintenance directly at concentrator plants. Each operation is carried out with careful attention, ensuring equipment performs reliably and processes run without unexpected interruptions. When a steam turbine breaks down, it doesn't wait for convenience, and neither does this service center. At Siemens Energy's Mulheim facility, turbine parts arrive coated in grime after years of operation. Step 1. Inspection and disassembly. Whether it's a full machine or individual components, everything is dismantled and cleaned, sometimes with sandblasting, before any evaluation begins. Technicians photograph each stage for traceability and documentation. Crack testing, endoscopy, and dimensional checks follow. If faults are found, repair orders are issued. Then comes machining, welding, and reworking, handled in-house with tools capable of processing up to 35-ton parts. Welders are certified for high-stress components, especially rotors and casings. The highlight? Vacuum rotor balancing at operating speed. It's the final stamp of quality before reinstallation. Achieving low vibration during balancing is a key performance benchmark. Field technicians coordinate with the repair team to align on-site assessments with workshop work. If needed, components too large for the main floor are moved to adjacent halls for heavy-duty processing. Flexible cranes and deep foundations support the handling of oversized assemblies. Everything is timed precisely. Customers often stand beside engineers during inspections, seeing the stripped turbine for the first time since removal. Their reactions: surprise, curiosity, relief, say it all. Behind every clean weld or polished shaft is a team that thrives under time pressure. This isn't just repair. It's trust rebuilt through steel, sensors, and steady hands. When a steam turbine breaks down, it doesn't wait for convenience, and neither does this service center. At Siemens Energy's Mulheim facility, turbine parts arrive coated in grime after years of operation. Step 1. Inspection and disassembly. Whether it's a full machine or individual components, everything is dismantled and cleaned, sometimes with sandblasting, before any evaluation begins. Each turbine that passes through this workshop tells a story of pressure, heat, and endurance, written in worn blades and faded coatings. Crack testing, endoscopy, and dimensional checks follow. If faults are found, repair orders are issued. Then comes machining, welding, and reworking, handled in-house with tools capable of processing up to 35-ton parts. The highlight? Vacuum rotor balancing at operating speed. It's the final stamp of quality before reinstallation. Field technicians coordinate with the repair team to align on-site assessments with workshop work. If needed, components too large for the main floor are moved to adjacent halls for heavy-duty processing. Everything is timed precisely. Customers often stand beside engineers during inspections, seeing the stripped turbine for the first time since removal. Their reactions: surprise, curiosity, relief, say it all. This isn't just repair, it's trust rebuilt through steel, sensors, and steady hands. cutting steel, welding, boring, inspection. Each step shapes this massive boom. This is what rebuilding strength looks like, piece by piece. At the Ferrioas machine shop, a certified reconstruction process breathes new life into a well-worn Cat 14H motor grader. The process begins with complete disassembly. Every component, from the frame to the hydraulic cylinders, is stripped down and carefully labeled. This isn't just repair. It's a ground-up reset. Each part undergoes inspection to assess wear, damage, and fatigue. Structural elements are measured against original specs, and anything beyond tolerance is replaced or restored. The frame is cleaned and resurfaced, creating the foundation for reassembly. Next, the engine block and powertrain components are rebuilt using original Caterpillar parts. High-torque bolts, OEM seals, and precision torque values bring the drivetrain back to peak condition. Meanwhile, the hydraulic system is flushed and rebuilt, ensuring responsive blade control under heavy loads. The cab is refurbished with fresh controls and updated wiring. This step isn't just cosmetic. It's about safety and operator efficiency. The grader's electronics are tested and calibrated to perform with factory-level precision. Even the operator's seat is replaced to meet modern comfort and ergonomic standards. Nothing is overlooked. Every inch is inspected and restored with intention. Reassembly demands experience and care. Major assemblies are mounted using torque specifications and alignment protocols that match Caterpillar's standards. Fluids are refilled, filters are changed, and the machine begins to take shape once more. Once assembled, the motor grader undergoes rigorous testing. Load checks, hydraulic pressure tests, and alignment verification ensure the unit meets performance benchmarks. Only after passing every inspection does it earn its certification. This certified rebuild isn't just about putting parts together. It's about restoring full functionality, reliability, and productivity. What rolls out of the shop floor isn't a patched machine, it's a Caterpillar reborn with purpose. Steel forging on a 13,000-ton press is nothing short of spectacular. Massive red-hot billets are lifted by a 450 metric ton manipulator, then shaped under pressure that shakes the entire floor. Each press cycle molds the glowing steel into form. Every slam echoes power. The operator must monitor the billet's temperature, adjusting for consistency and safety. Watching metal shift and stretch with each strike is mesmerizing. This process delivers enormous parts for heavy industry. Mitsubishi Nagasaki Machinery's forge turns raw steel into vital components that endure years of demanding service. There's something undeniably satisfying about shaping cold steel with your own hands. The MB31-6x50 Universal Manual Bending Tool brings craftsmanship to life, making metalwork accessible whether you're building ornate gates or simple workshop projects. This tool is engineered for flexibility. It can bend flat bars up to 50 by 6 millimeters, square stock up to 14 by 14 millimeters, and round rods up to 14 millimeters in diameter. Even first-time users will appreciate how intuitive the controls are, lowering the learning curve and boosting confidence at the workbench. Let's get into the action. The MB31-6x50 is mounted securely to the floor using its robust anchor holes, giving the user a solid foundation for every operation. A telescopic handle allows the operator to generate significant bending force with minimal effort, so even tough steel can be shaped smoothly. The stability this provides is immediately noticeable, making every bend more precise and repeatable. The quick change die system is a standout feature. Users can swap out different dies and stops in seconds to tackle varied bending tasks. When it comes to making decorative scrolls or volutes, the special 2-link die gets the job done cleanly and consistently. With this setup, the tool can form elegant spirals from 20 by 4 mm flat stock, letting fabricators add beautiful curves to window grills, fences, or wrought iron gates. Watching the steel curl into perfect arcs is always a thrill. But the MB31-6x50 isn't just for the artful side of metalwork. It's just as handy for functional bends, like forming precise angles in flat bars, or bending round rods on multiple planes. Sometimes, you just need a reliable bend for a bracket or a frame, and this tool handles it without breaking a sweat. There's no need for complex setup. The tool is ready for action right out of the box, and can be used anywhere: a garage, workshop, construction site, or even at home. An impressive set of dies comes included, letting users handle a range of metals and projects. Each component is thoughtfully designed for reliability and user comfort. The adjustment stops help create identical pieces without guesswork, making small production runs far more efficient. The MB31-6x50 brings serious capability to small workshops and professionals alike. Whether you're fabricating intricate scrollwork or just fixing something around the house, it adapts to every challenge with ease. That moment when cold steel bends exactly as intended, it never gets old. Clamps secure each pipe, and a hydraulic arm moves with immense power, shaping the steel along a carefully measured curve. The temperature and bending angle must be monitored at every stage to avoid cracks or deformation. Seeing the steel resist and then yield is honestly captivating. As the pipe cools, it's checked with gauges to confirm exact dimensions. This step-by-step control ensures reliability for demanding industrial applications. Even small miscalculations can lead to failures later, so every technician's role is critical. Watching the raw steel transform, you get a sense of respect for the engineering behind these powerful machines. Shaping a Bach trumpet begins with a single sheet of brass, and watching each transformation is honestly impressive. The bell takes form first, spun and hammered by hand until it reaches the ideal profile. Every tap and curve shaping the instrument's signature sound. Next, The lead pipe is drawn and bent, a process requiring both strength and finesse to ensure perfect airflow and response. Valves and tuning slides come together with remarkable precision. Every individual part is measured repeatedly to guarantee seamless assembly and reliable performance. Each valve casing is bored and honed to micro-tolerances, allowing lightning-fast movement. It's amazing to see technicians check every fit and seal, knowing a single imperfection could ruin the player's experience. Tuning slides are aligned, so notes ring clear and true, a detail that sets these trumpets apart in concert halls. Then comes assembly, where all the handcrafted components fit together like a puzzle. Soldering joins the bell, lead pipe, and valve block, each connection tested for airtight integrity. You can really appreciate the attention to detail as technicians polish the trumpet to a flawless shine, preparing it for its final test. When it's time to play, a skilled musician puts the instrument through its paces, checking intonation, tone, and response. Only after passing every test does it earn the Bach name, a tradition rooted in Vincent Bach's vision for excellence. Seeing the entire process, from flat brass to concert-ready instrument, it's hard not to admire the engineering, patience, and artistry behind each trumpet. These are not just products. They are tools crafted for musical expression, destined for symphony stages and passionate players everywhere. Step inside a modern fabrication shop and witness how automated welding has transformed the production of tank trailers. At the heart of this process is the IGM robotic welding system, designed for accuracy and adaptability. It all starts with the tank body secured in a specialized fixture, where mounting holes are precisely welded to prepare for assembly. This fixture allows the robot to rotate the tank, providing access to every required angle and seam. Once in place, the IGM robot takes over. With a programmed path and advanced sensors, it locates each joint and initiates welding with impressive accuracy. The robot's movements are fluid and controlled, applying consistent heat and speed along every weld seam. Thanks to these sensors and real-time feedback, the robot can seamlessly adjust to complex geometries, tight corners, or varying material thicknesses. It's remarkable to see how effortlessly the robot navigates intricate areas, producing uniform, high-quality welds, even in spots that would challenge a skilled human welder. The IGM system can handle multiple tasks at once, such as welding, repositioning, and inspection. This multitasking ability not only speeds up the workflow, but also ensures every weld meets strict quality standards. Each weld is closely monitored for parameters like penetration, temperature, and alignment. Any anomalies are automatically flagged for inspection, ensuring the final product is reliable and robust. Beyond quality, robotic welding brings significant safety advantages. Operators remain at a safe distance, away from hot metal and intense arc flashes, minimizing their exposure to risk. The automation also reduces human error and fatigue, leading to fewer mistakes and higher productivity. By the end of the process, the tank trailer emerges with flawless welds that are both strong and visually clean. Watching this blend of robotics and metalwork is a testament to how far technology has come. Today, tank trailers built with automated welding systems are engineered to last, meeting the highest standards for durability and precision on the road. Witnessing steel plates take shape at Vitco Steel is unforgettable. Massive slabs are heated in furnaces, glowing bright orange before entering the rolling mill. Powerful rollers flatten and elongate each plate with precision, controlling thickness down to millimeters. The roar of machines fills the air as technicians monitor temperatures and dimensions. Every step requires focus. Just one mistake could compromise the final product. It's amazing to see raw steel evolve into reliable plates used in bridges, ships, and heavy industry around the world. Precision engineering meets speed when milling a 12-spoke aluminum Rimstar on the Datron M8 Cube. This isn't just any part. It's designed for a Formula student race car, where performance and detail are everything. The journey starts with Autodesk Fusion 360, where engineers craft an exact toolpath, optimizing every movement for accuracy and efficiency. Every curve and angle is modeled virtually before a single chip of metal is cut. A solid block of aluminum is loaded onto the machine, locked down with a custom clamping fixture designed specifically for this shape. Watching the M8 Cube's spindle come to life is always a thrill. Its high-speed rotation creates a blur as the tool bites into metal, carving away layers with each pass. The surface finish has to be flawless both inside and out, which means tool selection and cut strategy are crucial. Long, rigid tools are used for deep pockets and thick sections. It's impressive to see how the machine tackles these tough cuts, maintaining stability and balance even as the tool reaches far into the metal. For each face, the machine executes dynamic, fluid tool paths calculated to save time without sacrificing precision. The sound of the spindle echoing through the shop is a reminder of the raw energy behind each operation. Operators monitor spindle load and tool wear in real time, adjusting parameters to maintain perfect results. Switching sides is a challenge of its own. The team removes the part, reorienting it with 3 precise location pins that fit into pre-drilled holes. The top is secured with a giant washer-like plate and 4 screws, keeping everything perfectly in place for the second round of machining. That fixture design is smart. It guarantees repeatability and accuracy every time. A single misalignment could ruin hours of work, so every setup is double-checked before machining resumes. As the final stage approaches, only the top section remains. The machine trims the part to its exact height and ensures a perfect fit for later assembly. The tolerances are tight, an 8H7 fit for the rim's interface and a 17H7 fit for the wheel hub, guaranteeing everything locks together seamlessly. The technician checks dimensions, feeling the smoothness and quality firsthand. Seeing the finished Rimstar up close, the clean lines and precise geometry stand out immediately. It's honestly satisfying to watch as the part is released. No rough edges, just a clean, beautifully finished Rimstar ready for racing. Every step reveals the value of careful planning and technical skill. The finished product isn't just a piece of metal, it's the result of smart design, efficient tool paths, and precise manufacturing. Seeing this process up close, it's impossible not to admire the teamwork and innovation that go into high-performance engineering for motorsports. Every stage of this vessel conversion is an engineering challenge. Massive hull blocks arrive by barge and are offloaded with self-propelled modular transporters, requiring perfect coordination and precise ballasting to line up with the key. Watching these huge sections roll into place is a feat in itself. Next, teams align the hull blocks and install overflows, discharge piping, and support structures. The deckhouse is assembled on site and lifted with a giant wheeled crane, then welded securely. Painting the hull is a careful, time-consuming step, bringing the vessel to life with its final colors. It's incredible to see the hoppers shifted by land, a massive effort that ends with the vessel ready for launch.